Hello and welcome back. In this video, we are going to go through some design decisions that we'll need to make when designing or building our microservices. I know a lot of students will send me messages because I've received messages like from students asking, why did you do it this way? Why didn't you do it that way? Okay. So here I just want to spell out some design decisions that I made and design decisions that we are going to make. Now, for these design decisions, they are not like written in stones. It's just something I decided to implement, the way I decided to implement them. You could decide to implement yours differently. Okay. You could watch maybe a different tutorial and you see that they implemented their APIs, they implemented their microservices differently. Okay, so here we want to talk about the design decisions that I personally made. Okay, and also if after going through this you have maybe some ideas that you think might be better, I'm always open. You can always send me messages, and I really appreciate those students that send me messages telling me okay how I can improve things. Okay, thank you guys very much. So here to go through the design decisions for this API that we are going to build, or the microservices we are going to build. Here, I've said this before, there's not going to be any direct client to microservices communication. Okay, so there's not going to be any communication directly from our front end to a microservice. Okay, every communication will pass through the API gateway. So we are not going to implement it so that users can send a request from the front end directly to the review service or to the chat service. Every request must pass through the API gateway, and we are doing this for security reasons. Okay. Another decision is all requests from client must go through API gateway. I've said it before, and the communication is going to be the synchronous, the request response with HTTP. We are also going to see how we will implement Socket IO, okay, for real-time communications. Another decision is that communication between API gateway and other microservices will be HTTP based and with Socket IO. Now, communication between our front end and API gateway will be HTTP based mostly. Okay, but also communication between our API gateway and other microservices will be HTTP based. Okay, so we are going to use HTTP for the communication to get to make a request and response from the API gateway to our auth service, from the API gateway to our user service, from API gateway to our chat service. And then for the services that require real-time communication with Socket IO, we are also going to implement the asynchronous communication between that service and the API gateway, and also the API gateway to the client. Another important thing is for Socket IO, we are not going to allow direct Socket IO communication between the client and a microservice. Socket IO communication as well will go through the API gateway. Okay, so the API gateway will not only be for managing the request, we are also going to have other functionalities within our API gateway. Now, inter-process communication between microservices will only be event-driven. Now, for all microservices that is not the API gateway, the communication will only be event-driven. There's not going to be any requests or HTTP request response. So, for example, if you want to send a message from your authentication service to your user service, you can implement HTTP. It's fine. You can do that. But for us, we are only going to implement the event-driven communication style. Okay, so the asynchronous event-driven communication style. So let's say your authentication service or maybe your auth service needs data from the database connected to your authentication service. The user service will not go to the database directly. Instead, it will send an event to the authentication service, and then the authentication service will send back a response. Okay, like I said, you can implement it with HTTP, but we are not going to do that. It's only going to be event driven, and we are going to use RabbitMQ. Now, you might be thinking, why RabbitMQ? Why not Kafka? I don't have a reason. It was a case of any, mini, many, more between RabbitMQ and Kafka, because I have experience with both and I just decided to use RabbitMQ. So there is no specific reason why I decided to use RabbitMQ. You could use RabbitMQ, you could use Kafka, okay? Now, token generation and management will be handled by the API gateway. Now, we are going to be using JSON Web Tokens, okay? Now, the microservices, they will have nothing to do with the generation of the token or the management of the token. Everything will be handled by the API gateway. All they just need to do is, if a request is coming from the API gateway, the specific microservice will just check, okay, does this have the required token? If it has the required token, then it will allow the request. But if it doesn't have the token, it will reject the request. But storing of the token or management of the token or generation of the token will be mostly done in the API gateway, except for the auth service, because when a user creates an account, there we are going to create the token and then send the token. We are not going to store the token in the authentication service. Once we generate the token in the auth service, we'll send it to the API gateway. And then the API gateway will store the token in its cookies, okay? So token generation and management will be handled by the API gateway, not by the services itself. Now, all microservices except API gateway will not be accessible from outside. Now, this is also for security reasons. Except the API gateway, every other microservices, we will not be able to access them from outside. So if you try to send a request directly, maybe you are using something like Postman, you want to test your authentication service and you send a request directly to the authentication service, it's going to fail because we will not allow any request to come from outside of outside into the service. All requests coming from outside must pass through the API gateway, okay? And then in this case, when a request is coming from the API gateway, we are going to attach a different token, okay? And that token, the service will then check, okay, this token that is coming, does it contain the specific value that I need to see? If it contains that value, it's just going to be a text. If it contains the text, then okay, this token is coming from the API gateway. But if the request comes with a token and that token doesn't contain the required value, we are going to reject the request, okay? So it's not going to, all services apart from API gateway will not be accessible from outside. Now, once we deploy to Minikube, we deploy to AWS EKS cluster, we're going to see how to test those as well. And then every request from API gateway will include a token. Okay. Now the token that is going to include will be different from the normal token for the authentication. This token will just be to validate and check that the request is actually coming from the API gateway. And then microservices will send client errors to API gateway, but other errors will be sent to the monitoring and logging system. Now for our applications, for each service, we'll connect them to Elasticsearch and Kibana, okay? Now for the server errors that are being generated by each microservice, the errors will directly go to the Elasticsearch that we set up, okay? But for the client errors, maybe invalid credentials, we will send that error to the API gateway, and then the API gateway will forward the error to the client. But for every other errors that are specific to that service, we will send the errors to the monitoring service. So these are just some of the design decisions that we are going to take, that we're going to implement. Now, like I've said, these design decisions are not written in stones. They can always be improved. If maybe you have a better idea, you can always drop me a message. I will appreciate it. I always appreciate it when you drop me a message. Okay, maybe we can do it this way, or we can implement it this way. But for the purpose of this course, these are the design decisions that we are going to take.